Hello guys, and welcome to another video. So on this video we'll be looking at a question of electric circuits. Now before I start, I just want to remind you that we have two types of electric circuits or connections. We have firstly the series connection, and we say a series connection will be a potential different series connections are potential difference dividers, and then we say the parallel connections are current dividers. In a series connection, the current stays the same, doesn't change, but in a parallel connection, it is the potential difference that stays the same. Okay guys, I hope you got that. Sorry. And now we go into our questions. The first question wants us to define the term resistance. Resistance has two definitions. The first one is that resistance is the opposition of flow of charge. Resistance is the opposition of flow of charge. Another definition for resistance is that resistance is the ratio of the potential difference in a resistor and the current flowing in it. Resistance is the ratio of the potential difference in a resistor and the current in that resistor. Okay, that's what resistance is, two definitions. And then we go to 5.2. They say calculate the equivalent resistance of the resistors connected in parallel. When they say equivalent, they want you to find the resistance in parallel, right? Equivalent total resistance in parallel. And they can also use the word effective here. If they say calculate, can I just fix here? Yeah, another word here, guys, can be effective. If they say find the effective resistance, they're saying find the total resistance on the resistors connected in parallel. Okay, so let's do that. When we find the resistance in parallel, this is where we are looking at these two resistors here, and there are two formulas we'll use. We use the formula 1 over Rp is equal to 1 over R1 plus 1 over R2. And when we substitute, we will have the first resistor. I always say the top one is R1. So it's going to be 24 plus 1 over R2 will be the bottom one. Then we'll calculate here, see what the answer is. So guys, when I put all of this on the calculator, the answer I'm getting is 1 over 6. But this is not the final answer. Remember, if you are using this formula 1 over Rp, you have to invert this. So these things have to interchange. The value at the top is to go at the bottom, and the one at the bottom will go at the top. So the answer will be 6 over 1, which is 6 ohms. So that's how you calculate the resistance in parallel. You can use another formula. That other formula is Rp is equal to R1 times R2 divided by R1 plus R2. This one is a straightforward formula. You don't have to invert. R1 is going to be 24. R2 is going to be 8 divided by R1 is still 24 plus 8. And then just punch all of these values on the calculator as they are, and you should get 6 ohms here as well. So you can use either this formula or this formula, but remember, this one you only use when you have two resistors. Okay, hope guys you got that. Okay, the next question says we have to find the total resistance of the circuit. Now the way we calculate that is to remember that we have the resistance in parallel, resistors that are in parallel, and we found this, the total of this, right? And the total of that was 6 ohms. And then we have this one. This one is the resistor that is in series, right? So here we have parallel, which is this parallel, and this one, the 2 ohms, is the resistor that is in series. So for us to find the total resistance, we will look at, remember we have 2 resistors here. So the one in red is in series, the ones in yellow are in parallel. We found the total of the parallel, which was 6, and this one in series is the 2 ohms. So when we calculate, we say RT, we are looking for the total resistance. That's 5.2.2, right? We are looking for the resistance, rather the total resistance. So it's gonna be the resistance in series plus the resistance in parallel. The resistance in series is what? It's 2, and the resistance in parallel is what? Is 6. 2 plus 6 is equal to what? 8. So the total resistance is 8 ohms. Okay guys, hope you got that. All right, here's another question that we have. The next question says, when the switch is closed, the voltmeter connected across the 2 ohm, this is supposed to be ohm, the 2 ohm resistor measures 6 volts. Determine the potential difference across the parallel combination. So guys, with this one, you will see that they are telling us that the 2 ohm resistor has 6 volts, right? And they want us to find the voltage on the parallel connection. So for us to find the voltage on the parallel connection, we will say that the voltage on the parallel connection is equal to the total. The total voltage is 24, and we know that once we get the total of the parallel, the connection will be in series, and we said series resistors are potential dividers. So that means the resistors in series should have different potential difference of voltage. So the one in series is 6 volts. What about the one in parallel? The one in parallel will be found from us subtracting 6 volts from the total voltage. So we'll say the voltage in parallel is equal to 24 minus 6. And if we say 24 minus 6, what is the answer that we get? We are going to get 18 volts. I hope you got that. So this basically means that the voltage in the or rather the potential difference across the parallel combination will be 18 volts. Now we go to the last question. 5.4 says, a charge of 18 coulombs flows through the battery in 6 seconds. Calculate the current in the 2 ohm resistor. And guys, let's remember that on the 2 ohm resistor, we are going to have the total current flowing through that resistor. And to answer this question, this is the formula that we use. You can either say it's Q is equal to I delta T, and the other one is I is equal to Q over delta T. Let's remember that Q is our charge, I is our current, and delta T is our time. Then from here we substitute what is Q. Q is measured in coulombs, so it is this charge. It is also stated here. So Q is going to be 18 divided by delta T. Delta T is our time, and this is our time. It's 6 seconds. Then from here we are going to say 18 divided by 6. What do we get when you divide 18 by 6? The answer we get is 3. And current is measured in what? In amperes. So that's how you answer this question, guys. I hope it makes sense. And yeah, see you on the next video. Please like if you did find this to be beneficial, and I'll see you on the next one.